Well, I guess I'd like to start by saying howdy. Howdy. Thank you for taking time out of your day and your schedules to participate in the CATEE conference. We're really glad to see you here and learn about some of the new developments that others are making, as well as report on some of the things that we've done over the last year. A lot of people inaccurately credit me for doing things. I want to make it clear, I don't actually do anything, okay? I read and edit reports and we talk about things. These are the people that do the work here, and they're sprinkled around the conference here, but clearly we need to give credit where credit is due. Myself and Mr. Yazdani are the co-principal directors of the TERP program at the Energy Systems Lab. Dr. Juan Carlos Baltazar is our chief manager of the simulations and all the technical underpinnings of the IC3 calculator, as well as the production of the annual report. Gally Silberstein is the assistant director of the lab and makes sure that we all keep things going straight. Vic Reed is currently retired from the lab, but was previously in the position that Gally Silberstein was in. Shirley Munns, who is here today, is our code specialist that we rely on a lot to keep us straight in terms of the code work. Jaya Mukhopadhyay now is at Montana State University, assistant professor. Previously, she was with the analysis group and did a lot of the code writing for the IC3. Tammy, of course, you all know. Patrick Parker and Roberto keep our computers running and keep many, many things going, which you don't even think about when you come to visit the calculator. But it requires a cluster of computers, and they have to talk to each other in a certain way, and when they break down, everything stops. So we're highly dependent on a lot of individuals for keeping these running. We also have Professor Emeritus Larry Diegelman here, who's pictured, as well as Sun Lok Do, Chunlu Mao, Sukjun, and Minjae, and Chimbo are students that are working on the project and getting a lot of the work done. So clearly what I'm reporting to you today is based on the labors of these people, okay? I just look at it, okay? But let's take a look at what we've done. So clearly over time you've heard that the lab is mandated to do certain work. And you can see that yourself. If you're having trouble sleeping at night, you can go back through the legislation. It started in 2001 with the 77th legislature, Senate Bill 5, some of the enabling legislation. That was then amended in 2003, amended again in 2005, 2007, 2009, 2011. Nothing happened in 2013, interestingly enough. And then, of course, what you've already heard today is that it was amended again in the 84th legislature with the passage of the 388 Health and Safety Code about the 2015 Energy Code becoming the code for the state in September 2016. So that's the enabling legislation that authorizes us to do what we do here for the state. In general, we have a set of criteria that we have to look at, and you can go to the EPA's website and you can parse this document. But this is what it asks you to do. It says if you're going to get air pollution credits from energy efficiency and renewable energy, you got to do the work. You got to quantify it. You have to make sure that it's surplus, it's not accounted for in some other program. You have to make sure that it's enforceable. So, you know, today you buy an efficient air conditioner. Well, tomorrow, can I get a less efficient air conditioner? These are some of the issues that have to be dealt with in quantification, enforceability. And then finally, we have to keep a record of this. We have to write it down and we have to publish a report. And that's one of the primary duties that the lab does. Each year, we roll it up and we publish a report and we deliver that to TCEQ. And that's the basis for the TERP program that the lab is working on. Now, in this, we calculate a lot of different emissions reductions. One of them are from code-compliant construction, primarily single-family residential. Although we do have a bit of multifamily, we'd like to have more, but it's not as strong as we have in single-family because of the reporting. And commercial as well, we have a bit, but we'd like to have more of that because it's a little bit harder to chase after some of the details with commercial. We have a layering approach, so each of these things, as you'll be seeing, we layer up from the bottom and then we count the top of the stack. We do have a lot of electricity savings now from green programs, primarily wind, and we work closely with the Public Utilities Commission on their efficiency programs that they have been promoting over the last several years as well. In particular, I have Senate Bill 7 here, which was a previously authorized program. We work with the State Energy Conservation Office as well to try to quantify and then calculate the emissions reductions from their energy efficiency programs that are reported to us. Oops, what's that? Sorry. There. And last but not least, interestingly enough, we became aware of the fact that clearly we can get the data for the air conditioners, SEER 13 and now SEER 14, that are sold as retrofits for buildings. So this is not new construction, these are retrofits, because each one of these things get counted, we know where they go, and we can quantify that. So those are the 5 basic things that we're quantifying at this point. We've got probably another 5 to 10 that we're working on to try to build into the quantification process, but in general, these are the 5 things that we're reporting. So first of all is our code-compliant construction. We rely primarily on our web-based IC3 calculator, International Code Compliance Calculator. This is the screen of the 2009 version. I'll be showing you the 2015 version here momentarily. You log into the screen, it's free. You have an account, you can have dozens, hundreds of different houses, you can recycle your designs, that sort of a thing. You log in, then it steps you through a basic set of information that you have to enter. The site address, the project details, the floors, the bedrooms, the foundation information, things about the windows, the mechanical system, the insulation, the HVAC system, the domestic water heating, the roof, the ceiling, shading. So you put all this information in about the house that you're building. It then gives you a report back. It says, okay, what's your house? What's the code compliance house? And then it checks it. So hopefully you're looking for this green check mark here, and that means that you meet code. And it's not just a checklist code, it's a simulated calculation. Okay? Once you get what you've done and you're satisfied with it, then you can then take that. It generates a full-page certificate with all the details, and it generates a little small certificate that you can print on a piece of sticky back paper and stick it on the meter for the house. And that's the whole point for that. So a couple years from now when somebody buys this house, they open up the electrical meter panel, there's the certificate. And that certificate is registered in our database. The 2015 version we've modified significantly based on comments and criticisms, whatever you want, from people that use it. One of them is more and more, believe it or not, people are running these simulations on their smartphone. It's just bizarre when I think about it. I can't even imagine that we would get there so fast, but that's what they're doing. They're running the web page from their smartphone. The problem is the way of displaying the results were supposed to be on a laptop, so it didn't look so good on a smartphone. So we had to rewrite the screens so you can see it better. So that's what's coming in the 2015. It's going to look better when you run it on your smartphone and when you run it on your tablet or whatever. So we still have the login screen, but now we have basically tabs that come up. And these are the listings of the tabs right here. So you tab your way around the thing instead of paging, which was not as efficient to do with a smartphone or a tablet. This is the tab now for the project details, site information, the floors, the bedrooms, the foundation, the global parameters on the building, number of floors, number of bedrooms, that sort of a thing. Any testing? Yeah, for example, some of the ductwork is going to need pressure testing to make sure that it's working with the new 2015. Roof information, as well as information about the foundation, the heating system, cooling system, and the water heater. So these are now tabs that pop up and go away as you navigate around the system. When you're done, you get a certificate We still print the small version of the certificate so that you can put it on sticky back paper and then put it onto the panel on your electrical system. So the 2015 version we will be rolling out in September 2016. We have a series of testers for that project right now, and we're working with them to make sure that we have something that's robust and, as much as we can, bug-proof, so that when we get it out there, you can use it with some confidence. Similarly, oops, oh, that's terrible. Okay, now you get to see what happens when Jeff collapses his file here. Okay. We have a new product that we're developing, again, based on requests from people. We've had several software providers for code compliance software that said, we want to put our front end on your engine. Well, we do that with an API. So now we've developed a backdoor to the calculator, and you come into the backdoor on the calculator, you knock, knock, knock on the door, you hand it the parameters, it runs the simulation, hands the answer back to you, and off you go. So we've developed that. It's in the process of being tested and deployed. We've got several entities that are going to be releasing new front ends for it, but it's using the same calculation engine. It is more tablet and iPad friendly, and of course, since we're using an API, we're now using an XML input and output to it for those of you that speak geek and do that sort of a thing. Importantly, it opens up then the use of this public calculator to private entities that want to put their own wrapper around it and do whatever they want with it. So we've decided that's another way that we can help people build more efficient houses. Now, how much has actually been saved from code compliance over all the different versions of the code that we've had to account for? So when we add all these things up, we're now up to and knocking on the door of the 2015 IECC. So we go to the entity that gives us the count on the residences in the state, and there it is for 2014, around about 100,000 houses. Okay, and then we do the calculations with the calculator. Once we have that in hand, we can then calculate how much energy was not purchased because the house is more efficient than the house that would have been built before the 2000-2001 code. So we see now, as of 2014, that's about $1.5 billion in electricity savings, about $1.7 billion in demand savings. So that's more than a power plant that we didn't have to build because our houses are more efficient, totaling about $3.3 billion. At a cost of only as much as we can estimate, about $1.2 billion. So there's a cost payback already in terms of people getting their money back when they build their houses more efficiently. That, of course, as I said, is about 1.2 megawatts that are not having to be produced in the state, so that's a bit more than a power plant that didn't have to be built. And, of course, the NOx emissions reductions, which is what the legislature wants us to calculate because we have ozone problems here in Texas. For the code compliance, it's as if you removed 20,000 cars from the road. So today we have that much less pollution in terms of the NOx emissions reductions. There's also water savings when you're talking about electricity generation. So in particular, when we take the megawatt hours that are saved, about 1.4 million megawatt hours, we then calculate how much water that is, okay? And we have some ways of doing that. We figured it's about 600 million gallons per year, which is about 1,916 acre feet. And if those of you that don't remember what an acre foot is, it's an acre of land with 1 foot of water sitting on it. So you can begin to get the mental picture. That's a lot of water that we're not having to consume for the electricity that we didn't have to use because our houses are more compliant. We're also looking at renewables, solar, solar thermal, solar PV, hydroelectric, biomass, landfill gas, as well as geothermal, and of course wind. Okay. First and foremost, we've been looking at wind, and for that information, we go to the ERCOT and they give us the amount of data in the ERCOT region, the wind farms. We add to that the data from the Western Systems Coordinating Council, the Southwest Power Pool, and we get our total count on our wind projects. To date, there's 97 of these wind farms that have been completed, 52 have been announced, and 2 have now been retired, interestingly enough. Okay? So all that data then gets accounted for, and we run the numbers. So starting in 2004 up through now 2014 and beyond into 2015 a little bit, you can see, looking at the graph here, that it ebbs and flows each year. The little banded sections right there are, of course, the ozone season period when we really need to have that wind power. And as we can see, it is actually increasing even during the dog days of the summer when there's no wind blowing. That's an interesting thing. We weren't expecting to see that. So in general, we've seen our installed capacity reaching a limit of about 14,000 megawatts. About 13,000 of those megawatts are in the ERCOT region. The total amount of wind power generated in 2014, coming from data from ERCOT, was 3,932 gigawatt hours per month. Total then out for the year is 34,000 gigawatt hours. So it's substantial. And I don't know about you, but if you've ever driven out into those parts of the state where they have the wind farms, I don't know, but I like it. I like seeing those things dancing in the wind air. Yes, there are environmental impacts with some of the birds and that, but I think the benefits to the state far outweigh some of the things that we have yet to figure out on those wind turbines. In the Bryan College Station area, we are also one of the highways that they can actually ship these towers on. So interestingly enough, there's days of the year when I come out of our lab and there goes another wind tower right next to us. And it is something to see one of those on the highway. So clearly, things are making a difference. And as you can see from the graph there, they're making a difference during the ozone season period, which are the lower portions of the graph each year. We also have been asked by TCEQ to check to see if these wind farms come online, do they stay online, every single wind farm? So we check the data that we've gathered over the years, and clearly, wind farm by wind farm, so in this case, I'm showing you data from Forest Creek, about 124 megawatts. It's actually running slightly above the design capacity that it was built to design at. So the answer for that plant is yes. Over all of the wind farms in the state, we classify them in terms of those wind farms that are running at full capacity, about 20 of the sites, 95 to 99% capacity, another 20 sites, 24 sites running less than 95% capacity, and then we have a few sites that are well below capacity for one reason or another. So we're carefully watching that so that we can continuously answer the question, can we rely on wind to help us to reduce our NOx emissions in the state? And we think the answer is coming back repeatedly, yes, yes, but you've got to do the numbers to really check it. There are, of course, other things we have to do with the data once we calculate it, and this is where it gets kind of weird, but the TCEQ and the EPA require us to go back to the base year. So wind farm by wind farm, we have to build a little model, and then we have to drive that model with the wind data from the 2008 year. So we cast backwards into the base year to do the calculations. When we do that with the annual wind data, there's about a 12% decrease because the wind was less in 2008. When we do it with the ozone season period, there's about a 23% decrease because the wind was less in 2008 compared to 2014. So additional sets of calculations that we have to run. There are, of course, all of these things pulled together and then calculation of the NOx emissions reductions. And sometimes I even myself get to the point where I need to have a mental picture of what are we doing, okay, to sort of guide the calculation process. So I had the staff develop this graph. And basically the idea is we count those parts of the network here that are jiggling. Okay, so we figure out all these measures that we've calculated. Then we cast those back to the power plants that they came from. So we use the actual published results of what power came from what power plant from the previous year. We cast it back to each of those power plants. And that's how we do the NOx emissions reductions. So eGrid that we're using right now is the 2010 version. It's a giant table. It shows you more or less if you purchased electricity from this power plant in this county, this is how much pollution was generated per megawatt by that power plant. We then divide it up into the congestion management zones in the state. There's essentially 4 of those zones, and then we use that to guide our calculation. Here's the west zone, there's the north zone, south zone, and Houston zone. So we have to figure out where did the power get saved and then where did it come from. That's all done with the eGrid table. This is what the 2010 ozone season day eGrid looks like, and this is, of course, what it looks like when you map the wind data onto that in terms of where is the wind data being generated, and then we take it back to the power plants. This is an idea, for example, using colors of where those power plants are located. We do the same thing for the ozone season period, which is, of course, that period of the year when we're trying to reduce the NOx emissions reductions. This is what it looks like graphically when you do the calculation, taking it back to the 2008 year for the wind power for the ozone season period. And then, of course, from 2014, we march that out into the future. So we have to add a degradation factor, we have to add a discount factor, and this is what it looks like as best as we can calculate out into the future what we think that these power reductions are going to look like. We do the same thing again here with the emissions reductions. In this case, we're looking at the ozone that was previously on the graph shown as megawatt hours. So that's the renewables. The wind is the green portion. And you can see just barely, there's some other things stuck on top of that green portion. That's the other stuff in the state. That is essentially the solar thermal, solar PV, landfill gas, hydro, and biomass. So each year we send out the call, we gather the data, we put it back together, and we stack it on top of the wind. So you can see from that graph in the upper right, wind is huge in importance. But the other entities that are renewables are starting to make a difference. The solar is fairly reliable. It's growing each year. The landfill is very steady. The hydro increases and decreases with the rainfall, which is like, duh, okay? And so does the biomass. But we didn't know that before we started in terms of what's the magnitude of that. Now we do. Solar PV, according to our best count, 2014, there's a little bit more than 4,600 projects around the state, 20 big biomass projects in the state, 27 hydroelectric projects, 34 landfill gas projects, and about 286 active geothermal projects in the state. A lot of this data is coming from the National Renewable Energy Laboratory as well as from ERCOT and PUC. So clearly, that's the roll-up that we do for the renewables. On the public utilities section side, we work with them to gather up the information from their incentive rebates program. We also have looked at their REAP program, Residential Energy Efficiency Programs, and as best we can, those programs are rather flat as far as we've seen lately. We would expect them to grow in the future, but we can't simply put that into the graph. We have to project a flat projection into the future. Similar sort of thing for the State Energy Conservation Office programs, as well as the school districts, government agencies, and political subdivision programs that they have. We get the savings calculations. 2014, it stepped up quite a bit over 2013. We're projecting that flat out into the future because we really don't know whether those programs are going to rise and fall, but we do the accounting with the basic numbers that we have in hand from SECO. So all of this gets pulled together across all these agencies. So that's sort of the list of the boxes along the top there. Those things have to be mashed up with a uniform set of multipliers. So the state agencies that we're reporting, of course, are ourselves with Texas Engineering Experiment Station and the single-family, multifamily commercial savings, the Public Utility Commission savings that I mentioned, State Energy Conservation Office savings, the wind savings through the ERCOT data, and now the SEER 13, now rolling to SEER 14 savings on the retrofit air conditioners. All of those need to then get calculated in terms of the total annual as well as ozone season period savings, and then the emissions reductions can be sorted out and viewed by program, by county, by SIP area, or by ERCOT county. So there's different ways to view it as well. Each of those are presented in the annual report. And also, one other thing is quite often some of the cities now are asking us for a radius around the particular city because they want to know what the NOx emissions reductions are as well. So the roll-up for this year is as follows. Code compliance is a little short of about a ton a day, 0.76 ton per day on ozone season day. Public utility programs are running about 1.8 tons per day. The State Energy Conservation Office reportings from their political subdivisions is about 0.6 tons per day. The green power is a whopping 11.9 tons of NOx savings on ozone season day. And of course, the residential air conditioner retrofits are about half a ton of NOx emissions reductions. We then take that, roll it out into the future with our degradation factors and our discount factors, and we're projecting about 22.5 NOx emissions reductions from all those programs. So in general, all of this stuff is on our webpage. I welcome you to download it and read it. It's a guaranteed cure for sleepless nights. It'll put you to sleep in a minute, okay? This is just a listing of some of the reports for 2014, some of the papers for 2014, and then ongoingly we're pushing out into 2015 with papers and publications. Now, one thing I want to end with, it's one thing if we say we're doing a good job. It's another thing when ACKNOWLEDGE says we're doing a good job. And this counts a lot. They just issued a press release now saying Texas finally deserves recognition for the improvements they've made on residential construction. In particular, adopting the latest building codes, and it's had a noticeable change in our building stock. Thank you, ACKNOWLEDGE. We knew that. So I'm going to leave this up here. This is just an animation that you can download from NASA that shows where the air quality problems are, in particular the oxides of nitrogen. You can see that clearly over the years, so that's the fainter version of it. It's getting better. We're not done yet, but it's getting better. So thank you to all of you for the work that you've done and giving us the opportunity to report it to you here at this CATEE conference.